We know that notes on a staff indicate which pitches we will hear in a piece of music. We know that high pitches are placed high on the staff or even above the staff with ledger lines, and that low pitches are placed low on the staff or below it with ledger lines. But how does the staff show us which specific note to play? Even though there are thousands of possible pitches of audible musical sounds, the number of notes is much more limited. The best way to learn about notes and note names is to look at a piano keyboard. Typical pianos contain 88 keys. Some of them are white and some of them are black. Each key produces an individual pitch, a unique pitch. Keys on the left, played with your left hand, produce low pitches, like these. And keys on the right, played with your right hand, produce high pitches. Notice, however, that there is a repeating pattern of black and white keys. You have 2 black keys and then 3 black keys. Then 2 black keys, 3 black keys. 2 blacks, 3 blacks. Surrounding these 5 black keys that can form this pattern are 7 white keys. Always. So this pattern shows us that even though there are 88 unique pitches, we really only have 12 notes. The 5 black keys and the 7 white keys that repeat themselves as they get higher if you move right, or as they get lower if you move left. For now, we will focus on the white keys. The white keys give us the notes' letter names. Each note has a letter name here. I know that there is a different system in many countries of Latin America and Europe and Asia where the notes have individual proper names, right? In America, we use those for solfege, which is a different topic. So for notes themselves, we only use letter names. The white key immediately before the group of 2 black keys is called a C. The next white key then is called D, and then E, F, G, and then we start over at A, B, and we return to C. C is an important note for many reasons. One of them is that right on the middle of the piano, we have a note called middle C. It sounds like this. It is special not only because of its location on the keyboard, right at the middle of the keyboard, but also because it's right around the area where the typical male and female voices meet, right? It's that in-between range there. It's not too high and not too low. So you can see that C's are always located at the same spot of the pattern, always before the group of 2 black keys. And all of the other notes, the same, right? So D is always the one that comes after C or between the 2 black keys, etc. Remember how we defined steps and leaps on a staff? Here are some examples on the keyboard. Now, those are not necessarily correlating what you see on the staff, what you would play on a keyboard. Rather, it's just the idea that you have an ascending step on the staff here, and here you have an ascending step on the keyboard. Same thing. Here, descending steps and descending leaps like that. So you can see that adjacent white keys produce steps and non-adjacent white keys make leaps. Ascending motions on the keyboard go right and descending motions go left. From these observations, we see that steps always involve adjacent letter names like A, B, or B and C, or if you're going down, A, G, G, F, and etc. Between steps and leaps, almost every possible melodic motion in music is covered, except for one thing, a repeated note. In music, we call it a unison. It's played using the same piano key, and so the note has the same letter name, and obviously it produces the same pitch, like this. So that's a middle C, played in unison there. On the other hand, when you play 2 different keys of the same name, you're playing an octave, like this. Octaves are real special leaps because the note names, even though they're the same The pitches are very closely related. There's actually a mathematical function that is quite simple that dictates how they are related. And what this means is that these two pitches, which have the same note name, but they're located in different parts of the keyboard, they sound pretty much the same, only one is higher or lower than the other. Notice also how some of these steps between white keys have a black key in between, like C and D or D and E, and some steps do not have a black key in between them, like E and F and B and C. Steps that have the black key in between them are called whole steps. So look at C and D. There's a black key in between them, so it's a whole step. Steps that do not have a black key in between are called half steps, like E and F. Both types are called steps. They move between adjacent white keys and adjacent letter names, but whole steps are larger than half steps and sound a bit different. Listen to a whole step starting on C to D, right? And a half step moving from E to F. It's a very subtle difference, and it's possibly best understood if I start on the same note. So going back to middle C, here's a whole step starting on C. And if I start on that same C and produce a half step, it sounds like this. Right? So the basic idea is whole steps are larger than half steps. Another name for half steps is semitones. Semitones are really special because in what is called equal temperament music, that is most classical, jazz, pop, rock music, pretty much most of the music you've listened to, semitones represent the shortest distance between two adjacent notes. So if you start on C and go a semitone up, that is, if you go up the shortest possible distance between two different piano keys, you must land on a black key. That's your next possibility, your closest possibility. So if the whole step between C and D, right, has two semitones, because you go from C to the black key, that's one semitone, and then you go from the black key to the up to the next available key, which is D, 2. So it happens that all whole steps are like this. They always have two semitones or two half steps within them. But what do you call this black key? The black key that happens to be between C and D, or for that matter, any black key between D and E, F and G, G and A and B. So we only have really 7 letter names, and those derive from the wide piano keys. Right? So you have A through G, basically, or if you're starting on C, from C to B. So when you're landing on a black key, that black key will borrow the name from a white key and add to that name something that we call an accidental. So accidentals indicate the location of the black key in relation to a white key. Accidentals are little symbols that tell you, in other words, what the closest white key is. If you go up a semitone from a white key, you use a sharp, right? It's like a pound sign or a hashtag. If you go down a semitone from a white key, use a flat, which is like a little b. So the black key between C and D can be either called a C sharp, if you're thinking of C and going up a semitone, or a D flat, if you're thinking of D and going down a semitone. So it all depends on your point of reference. Notice that all black keys have 2 possible names because of the 2 accidentals, right? Because there's always a white key before it and a white key after it. Choosing one name over the other, like C sharp instead of D flat, is an important distinction, but it's not one, once again, that we need to concern ourselves with right now. It's a topic for a much later discussion. I think that for now it's sufficient to know that these black keys can be called in one of 2 ways, either with a sharp or with a flat. So when we refer to the same black key that has two different names, see here F sharp and G flat, we call them enharmonic equivalents. That means that there are two notes of different names that produce the same pitch, like C sharp, D flat, D sharp, E flat, and etc. Okay, one last word about enharmonic equivalents. It's important to notice what happens when you apply an accidental to a white key that does not have a black key before or after, like E, F, B, and C. So what is an E sharp if you don't have a black key here? Or what is a C flat if you don't have a black key there? We follow the same logic as before. Sharp, semitone above. Flat is a semitone below. So E sharp is enharmonic with F. C flat is enharmonic with B. F flat is enharmonic with E, and B sharp lands on the key that is enharmonic with C. There are no black keys for these accidentals, so they're played in regular white keys. So it's good to remember that even though they produce the same pitch, say E sharp and F, right? You play them using the same piano key, or if you play a string instrument or a wind instrument, the same fingering or the same position of your finger. Even though they sound the same because they produce the same pitch, they're still different notes. They have different letter names. And this distinction, once again, is not one that we need to concern ourselves too much right now, but one that will become important in the future and one that is important for you to understand at this present moment.